So, like I said, we were working on acceleration yesterday. Now we want to look at some problems that have to do with picking the right formula. Okay, you're not being told ahead of time what formula to use for this question. So we got to figure out first off what we're looking for and what we're given. Question says, what's the final velocity? All right, so I know I'm looking for VF. Oh, sorry, it's not zero. It's a question mark. That's not a question mark. That's a question mark. Okay. Velocity of a rock that is propelled over a 0.3 meter distance by an acceleration of 22 meters per second squared, okay, and it's over a 2.72 second interval. All right, so I've got D, A, and T, and I'm looking for VF. All right, what formula do I have that has those four things in it? Okay.
Acceleration equals VF. Subtract 1/2 AT squared.
Yeah, VF, well, that's actually not acceleration, it's D equals this one, right? This is the one you're thinking? Okay, so I've got VF times T minus 1/2 AT squared, and I'm looking for VF. Okay, so the first thing I need to move is the 1/2 AT squared, and I'll do that by doing the opposite, which is adding it. So I'll have D plus 1/2 AT squared equals VF times T. So we'll divide both sides by T, and now we're solving for VF. So if we plug in our numbers here, we'll have 0.3 meters times, plus 1/2 times the acceleration, which was 22 meters per second squared, okay, times 0.72 squared divided by 0.72. Okay, so that's what our equation will look like. Okay, so 0.3 plus 0.5 times 22 times 0.72 squared divided by 0.72. All right, so we're looking at 8.3 meters per second as our final speed. Okay, everybody all right with that one? Okay, so the trick here is write down your givens. Okay, so you can figure out what formula it is you have to use. Okay, try this one. All right, so we're looking for the initial velocity of a bullet that enters ballistics gel. That's the stuff they use when they're testing, when like doing crime scene investigations. They want to see how far away a shot was fired from. Okay, and slows at 150 meters per second squared for 0.252 seconds if its final velocity is 65.2 meters per second. In other words, it was a through and through. Okay, went in one, out the other side, which is often what happens when something gets shot. The bullet very rarely actually lodges inside. All right, let's, is everybody ready to have a look at this one? Yeah. Okay, so for writing down our givens here, we're looking for VI. They're asking us what the initial velocity is. Okay, it enters ballistics gel and slows at 150 meters per second squared. So that means the acceleration is negative. Okay, and that's important for me to realize when I'm plugging in my numbers. And it does that for 0.252 seconds. And its final velocity is 65.2 meters per second. All right, so what formula am I using for this? Right, the one from Science 10, VF minus VI over T. Okay, we were given T, we were given VI, and we were given A. Right, so we're solving, we're given VF, sorry. So we're solving for VI. So what I'm going to do is first multiply both sides by T, then I'm going to add VI so that it's positive, and then I'm going to subtract T times A. So what I'll be left with is VI equals VF minus T times A. Right, are you with me there? In other words, final velocity minus the change in velocity gives me the initial velocity. All right, so we got 65.2 minus 0.252 times negative 150. Okay. so 65.2 minus 0.252 times negative 150. All right, so we're looking at an initial velocity of 103 meters per second, which is not a very fast bullet. Okay, this bullet had obviously already been flying for a long way, and it's slowed down a lot. Okay, because that's pretty slow for a bullet to be moving at. Okay, only 103 meters per second. Okay, maybe it's like an old musket ball or something. Okay, not like an actual bullet. Okay. Is the acceleration that would be experienced by a real bullet going into something like ballistics gel, is it going to be pretty large? It is. Okay, that's what causes all the damage. Okay, that and usually the bullet will change shape and kind of partially disintegrate as it goes through and leave little pieces of itself. That can be really harmful. Okay, but it's that massive deceleration. Okay, that's the thing that, you know, causes people to fall, it causes damage to bodies. Okay, but we get this idea that because there's a massive acceleration, that what goes on in movies is real, and that is like somebody gets shot and they fly back 10 feet. Okay, is that realistic? Not at all. Okay, the acceleration for the bullet may be incredibly large, but the bullet's mass is incredibly small. Okay, your acceleration, because your mass, or the ballistics gel's acceleration, because its mass is so much bigger, is actually quite small. Okay, and so you don't see people flying backwards from a shotgun blast or something like that like you do in the movies. It's very unrealistic. Okay, and the way they do that in the movies is they attach cables to that person. They fire the gun, and then they have the guy yank the cables, and they fly back. And it just looks cool on camera, but it's not at all realistic in any way. Okay, have you try this one. How far a plane flies while accelerating at positive 4.52 meters per second squared from a velocity of 123 to 300 meters per second. So you're looking for D this time. Okay, so we're looking for how far the plane flies, which means we're looking for D. Okay, it's accelerating at positive 4.52 meters per second squared. Okay, and it's changing its velocity from 123 to 300 meters per second. Okay, what formula am I going to use there? Right, the VF squared formula. Okay, so we're going to use VF squared equals VI squared plus 2AD. Okay, now I often have people who will ask, well, Mr. Quitter, what if I didn't use that formula? What if I did this in 2 steps? Okay, I mean, it's fine to do it in 2 steps, but on a unit exam where time's a factor, probably want to do it in 1 step. It's faster. Okay, so I'm just putting that out there. There's nothing wrong with solving and getting the right answer using 2 steps. It just takes you twice as long to do it that way. Okay, so we're trying to solve for D. Okay, so we're going to subtract VI squared over to the other side. So we'll have VF squared minus VI squared, and then we'll divide by 2A to leave D by itself. Okay, so we'll be left with that. And then when we plug in our numbers, okay, we'll have 300 squared minus 123 squared divided by 2 times 4.52. Now, important on your calculator here to make sure that you enclose things in brackets or do this step by step. Okay? If you don't, your calculator will try and do it from left to right, which is not what we want. Okay, so this thing is going to travel 8.3 kilometers, or 8.3 times 10 to the 3 meters. Okay, everybody all right with that? That's, I find, the formula people forget about. Okay, they forget to use that one when they're given an opportunity to do so. Okay, for this one here, see if you can find the initial velocity of this runner who finishes a race at 15 meters per second. The race was 150 meters long, and it took 21.2 seconds. So in this one, we are looking for the initial velocity, okay? So we're looking for VI. Okay. They tell us that the VF is 15 meters per second. They tell us the race was 150 meters long and that it took them 21.2 seconds. All right? So it's an accelerating object, but I'm not given acceleration. What's my only acceleration formula that doesn't contain acceleration? What should I have said in this question? Right. So I told you anytime you use this formula, the question will probably say the object is accelerating uniformly. I didn't mention that in this question, which probably made it a little tougher for you to pick this one out. All right. So this is the formula we have to use, though. It's the only one that has what we have and what we're looking for in it. Could you have done it in 2 steps? Yeah, you could have calculated acceleration using these 3 things and then gone back to find VI using any one of the other formulas. But this will find it in 1 step. Okay? So I'm going to first divide both sides by t. So I've got d over t equals VI plus VF over 2. I'm going to multiply both sides by 2 and then subtract VF. So what I'll be left with is 2d over t minus VF equals VI. Right, so that'll be 2 times 150 divided by 21.2 and then subtract 15. So we got 300 divided by 21.2 minus 15. All right, so they are moving backwards slightly, okay, at negative 0.85 meters per second. Does that seem weird given the context of the question?
I
mean, if it's a race, how many people start a race going backwards? The losers, usually, okay? But actually, no. If you're in your starting blocks and you don't really know how to use them, because I've seen people do this, they'll rock backwards in the starting block as the gun goes and then push forward thinking they need to load up, and they don't, okay? So you will actually see people who rock backwards and then go forwards, okay? So it's not uncommon to see somebody actually moving backwards initially. I will always try to make questions make sense within the context of the question, because probably that answer would have thrown most people going, it's a race, why would they be going backwards at the beginning? Okay. All right, any questions on that one? Okay. Are these acceleration formulas and problems sort of making sense? Okay. It's really just algebra, right? You have to pick the right formula, manipulate and solve. That's really all there is to it. Okay, not much more than that. Okay, let's skip that one. These are in your workbook, your digital workbook. Okay, I want you to see if you can just work on a few of these and see how we do. Okay, I'll put the digital workbook up